Assalamu alaikum students. Today the topic is energy, work and power. So let's start the topic. Question number 1. A car of mass 1800 kg is towing a trailer of mass 400 kg along a straight horizontal road. The car and the trailer are connected by a light rigid tow bar. The car is accelerating at 1.5 meter per second square. There are constant resistance of force 250 Newton on the car and 100 Newton on the tow bar and the tow trailer. Find the tension in the tow bar. So we will use Newton's second law, that is resultant force equals mass times acceleration. So resultant force is actually the difference of the two forces, the tension minus frictional force equals mass into acceleration. We are supposed to calculate tension over here, tension in the tow bar minus friction. Friction is 100 Newton and the mass is 400 kg into the acceleration is 1.5 meter per second square. So when you multiply 400 with 1.5, it gives you 600, and tension minus 100, so tension will be equal to 600 plus 100, it's giving you 700 Newton is the final answer. The tension in the tow bar. Part B of the question is that find the power of the engine of the car at the instant when the speed is 20. Again, I am using my Newton's second law. The resultant force, that is equal to mass time acceleration. So resultant force equals mass into acceleration, and resultant force is the difference of the two forces, like driving force minus frictional force. This is the frictional force into mass. Now it is the combined mass of the engine. It should be like 1800 plus 400 into acceleration, that is 1.5, and driving force can be calculated by the power over velocity, and friction is 100 plus 250, that's equal 1800 plus 400, 2200 into 1.5, that will give you the result 3300. Using your calculator, we are supposed to get our power. So this is power over velocity. Velocity is 20 minus 350, that is equal to 3300. So its power over velocity, that is equal to 3300 plus 350. So 3300, and it becomes 3650 power over velocity. Now final, the power equals 3650 multiplied by 20, and the final answer is 73000 watt. So this is the power of the engine of the car at the instant when the speed is 20 meter per second. Now coming to the question number, next question. A child of mass 35 kg is swinging on a rope. The child is modeled as a particle P and the rope is modeled as a light inextensible string of the length 4 meter. Initially, P is held at an angle of 45 degree to the vertical as shown. Given that there is no resistance force, find the speed of P when it is traveled halfway along the circular arc from the initial position to the lowest position. So at the start we are going to get our height. This is cos 45 degree. Cos 45 degree equals height divided by 4, because it is a triangle, so 4 times cos 45 degree. So cos 45 times 4 gives you the answer 2 into under root 2 meter. This is the height. Second, it becomes half. The angle becomes half. So we will get the second 22.5 degree equals h1 over 4. So here h1 will be equal to 4 times cos 22.5 degree. So the final answer is, and you use your grab your calculator and get the calculation. So it will give you 3.6955. When you obtain the two heights, the height number 1 and this is the second height, then you can say the loss in gravitational potential energy, is equal to gain in kinetic energy. So mgh, the mass is 35 into g, that is 10, and the difference of the height, first height is 3.6955 minus 2 into under root 2 equals half mv square. Mass is 35 and into v square. So on the left hand side, by using the calculator, we are obtaining 303.4755 equals 17.5. Half of 35 is 17.5. So v square equal, when you divide this thing, 303.4755 divided by 17.5, and the velocity we are obtaining is 4.16 meter per second. Find the speed of the P. This was the speed we wanted to calculate. So this is the speed we get from this part. It is given instead that there is a resistive force the work done against the resistance force as P travels from its initial position to its lowest position is xj, The speed p at its lowest point is 4 meter per second. Find the x to first of all get decrease in height. Four minus 2 under root 2, it will give you 1.17157. So we are going to use the formula law of conservation of energy, means loss in GPE, loss in gravitational potential energy, is mgh. So the potential energy will be, mass is 35, g is 10, and height is 1.17157. So the potential energy calculated will be 410.05 joule. This is loss in potential energy. We know the work done against resistance will be loss in gravitational potential energy minus gain in kinetic energy equals work done by resistive force. So loss in potential energy we calculated in previous step, that is 410.09, and the kinetic energy will be calculated like 1/2 into mass is 35 into 4 square, and it will be your work done against resistance. So final calculation gives us the work done against resistance, x is 410.05 minus 280. So 130 is the difference. This is the work done XD, and it will be measured in joule. So students, we get the value for the x. It is given instead that there is a resistive force. The work done against the resistance force as P travels from its initial position to its lowest point is xj. The speed p at its lowest point was 4 meter per second. So we just get the decrease in height, that is 4 minus 2 under root 2, and then I calculated the loss in gravitational potential energy, 410.09 joule, and the difference in the mechanical energies is the work done by the resistance. So loss in gravitational potential energy minus gain in kinetic energy is actually the work done by the resistance. So this was the question.